Okay, the last part of this unit is the idea of something called a titration. I'll give you the material on it today, and then I'll show you a video of the lab that we'll do, virtual lab on titrations tomorrow, and then your test for this will be due on Friday. So you can see that link right there. In the Google Classroom, when you pull these notes up, you should be able to click on that, and it will show you what Professor Dave says about titrations. So let's look. Titration is a technique used to determine the acidity of a solution. Now you could find the basicity of it as well. Remember, acids go from 0 to 6.99, neutral is 7.0, and then 7.01 and up to 14, those are bases, right? So essentially, what you're going to do is you have a known volume of a certain substance, and it's placed in an Erlenmeyer flask. Then you add to it a few drops of indicator, such as phenolphthalein. The solution of the unknown concentration is placed in a burette. Now, you can switch those. In the lab that we have done, the unknown was actually in the Erlenmeyer flask, and the known concentration was in the burette. This is a burette. Okay, it's got line markings, and these markings go to the nearest tenth of a milliliter. All right. Actually, you can measure this to the nearest hundredth, since there are lines that are going to the nearest tenth. This one actually starts at 0 and goes down to 50. And then there's a valve here that allows the liquid to come out through the spigot, through the spout here, and then goes into the Erlenmeyer flask. Now the Erlenmeyer flask is going to contain either your unknown or your known solution, and vice versa in the burette. So when we have, I'll just show you very briefly, I've got some sodium hydroxide here, NaOH, and I've got some acid in here, and just see what happens when I pour some of this in here. You can see that it turns pink. Now if I continue to stir that around, the pink disappears. The pink is because I had phenolphthalein in there. Now the idea is to add enough of the sodium hydroxide into the Erlenmeyer flask until it turns pink, but stays pink, very faint pink. If you put too much in there, it won't be as precise, and you'll have to start over. Okay, so that's the basic process of it. So the initial volume is red, so we could start at 0. And then as I add to this, as I open this up and stir it at the same time, always swishing it around, the volume will go down, 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 and let's say it stops on 11.2. That means I've used 11.2. Remember, the numbers here are going down. So from here to 1, if I go here, it's not 1 point something, it's 0 point something. So it looks, the scale is different, and it's a little bit easier to lose track of yourself. You've got to remember that it's the amount that's getting added instead of getting measured. So the initial volume on the reading is taken. The unknown solution is added until the two reactants have combined. This point, when it starts and stays pink, in this case, This is called the equivalence point. And then, most of the time, the equivalence point and the endpoint are the same thing. In certain acid-base titrations, it won't be the same thing, but for our purposes, the equivalence point is going to be the same as the endpoint. Okay? Then I find the final volume, how much either acid or base I've added, and then I just punch it into an equation. It's pretty straightforward. The solution with the known concentration is called the standard solution. So in order for me to figure out an unknown, I have to know exactly what the molarity is of either the base or the acid. Again, the indicator one color, so this is another phenolphthalein. It's clear until it turns pink, and that's in it's a base. So the indicator is one color in the presence of the acid and changes when it's either neutral or a base. The endpoint is when enough acid has been added to completely neutralize the base. Again, we can reverse that. We could have the base being the unknown and the acid be the known. It doesn't really matter. So, equal numbers of hydrogen, H+, and OH- hydroxide ions are needed for exact neutralization. Okay? So, for example, if I have sodium hydroxide, I can neutralize it with hydrochloric acid. This is reversible, but in a neutralization reaction, for every hydrogen that I have, it's going to combine with hydroxide to make water. And then the metal and the nonmetal will combine to form salt. So in any neutralization reaction, we've got an acid plus a base making water and salt. So this is a 1-to-1 ratio in this case. 1 mole of hydrogen ions reacts with 1 mole of hydroxide ions, and we get 1 mole of water. All right? Now, how do we figure out, once we have that, how do we figure out what the molarity is? Here is the relationship. MAVA equals MBVB. Earlier on in the solutions unit, we did a type of question called solution dilution. I'm not sure if we did it in regents, but I'm pretty sure we did, in which I have to, it's almost the same equation. I can take the molarity and volume of one and the molarity and maybe the unknown volume of a base to find out how much I would need in order for it to become diluted. Okay? So here's an example. It takes 83 milliliters of 0.45 molar NaOH, sodium hydroxide, to neutralize 235 milliliters of an HCl solution. What is the concentration? Like always, I'm going to start with my equation, MAVA, MBVB, where MA is the molarity of the acid, VA is the volume of the acid, MB is the molarity of the base, and the volume of the base is VB. All I do is punch my numbers in here, solve for MA, and I can get 0.16 for that. All right? Here's an example, and this is the homework that I want you to do for tonight. If it takes 54 milliliters of 0.1 molar NaOH, I first have to identify what is the base. Bases tend to end with OH. To neutralize 125 milliliters of an HCl, acids tend to start with H. What is the concentration of the HCl, the hydrochloric acid? So my equation, MAVA equals MBVB. What is the concentration of the HCl? So concentration, they're talking about molarity, so this is my unknown. I'm neutralizing 125 milliliters of that. I've got a molarity of the base of 0.1. and it takes 54 milliliters in order to do that. If I solve for MA, that's 0.1 molar times 54 milliliters over 125 milliliters. Cross those out, and then my final answer is going to be 0.043. Really, all of these are essentially the same. Give your equation, figure out what's what, punch them in, solve for your unknown, and then go from there. Okay? I'd like you to finish this for homework for tonight. Okay? I'll post the answers tomorrow. You also have a lab that's due in about 15 minutes and some Regents review book questions that are also due. I also posted that there is a spiral that is due on Friday. Put all your answers in the Google form. All right, see you next time.